Okay, we've got a contingency table. I've got information about the sex of drivers and the colours of their cars, and I'm asked to work out the expected frequency. So the method for that is we need to work out row totals and column totals, and then there's a formula we need to apply. This formula here, this is a couple of pages back in the notes, row total times column total over grand total. So adding up my row total, 6 and 6 is 12, plus 11 is 23, plus 3 is 26, plus 4 is 30. Okay, and these add up to 12, plus 16 is 28, plus 7 is 35, plus 29 is 64, plus 3 is 70. So conveniently these add up to 100. And then our column totals are 18 and 24 and 18 again and 32 and 10. So I have my row totals, column totals and grand total. So applying that formula for the first cell, I ignore that 6 completely. To work out the expected frequency for this cell, I need to do 30 times 18 on my calculator. So here goes. Well, I might be able to do this without a calculator, but never mind. 30 times 18, not 180, it tells me it's 540. I could use the calculator to divide that by 100, but you know what? I think I can do that in my head. So that's 5.4. So 5.4 or 5.40, either will do here. Okay, and then for the next one, we need to do, for this cell, we need to do 30 times 24 divided by 100. So change the 18 to a 24. So I can work my way across the row. This is going to be 7.2 after I've divided by 100. Okay, and because they're all times 30, all I need to do is change the second number. In fact, this next one is an 18 for the column total again, so it's going to be 5.4 just as I got here. Next one, I've got 32. I change my 24 into a 32, and I get 9.6 as the expected frequency. And for this one here, 10 times, I can do that in my head, that's 300 divided by 100 is 3, or 3.0 or 3.00, any of those would do. Okay, and then I can go on the second row. So for the second one, I can do, for this cell here, I can do 70 times 18. So 70 times 18 divided by 100. I did divided by, which I didn't mean to. 70 times 18 is 1260, divided by 100 is 12.6, and so on. Now, when you get to the final expected frequency in each column, you can carry on using the formula like I just did, but you can also work backwards because what the method here preserves the total. So this total for the column of 18 has got to be valid for the expected frequencies as well. So I could have got this 12.6 by taking the 5.4 away from the 18. So it's your choice. You can carry on using the formula as we did here. For the next one, I could get this expected frequency by saying it's 24 minus 7.2, which gives me 13.8. This one here, well, it's a same total as this column, so 12.6 will apply again. Okay, this one here, 32 minus 9.6, that was that 9.6? Yes, it was. Didn't write it very well. So 32 take away 9.6 is 22.4. Okay, and these have to add up to 10, so this must be 7.0. And I could double check that these add up to 70 as they should. So I've got my expected frequencies. Now the next question says, Part B, says explain why a chi-squared test cannot be performed on the data in this form. Okay, so there is a restriction that applies that you need to know about, which is that expected frequencies have to be at least 5. So I'm not in the least bothered about this 3 or this 4 because these are observed frequencies. But I am bothered about this 3 here. This is an expected frequency of less than 5, which is not allowed. Okay, so the reason why is the expected number for males with yellow cars is less than 5. So the chi-squared test is not allowed, is invalid. Okay, so the way we deal with this, we'll see in the next problem. So next video, we'll look at how we, well, it's done for us, that we combine the groups of cells to make sure the expected frequencies are not going to be less than 5.